Hello Physical Science, this is Mr. B, and today we are going to start a completely new unit actually, and our unit is on physics because that's basically the other half of physical science is what is called physics. And physics is basically, if you remember from class, the study of, I think, matter, motion, and energy. So it's basically how things move, how energy can be transferred between those things, being the matter, and I don't know, that's basically about as simple as I can get it for now. I could go into a whole probably 10-minute video about what physics actually is. For now, one of the big things with physics is how things actually move and the energy that they create. So the chapter that we're going to introduce ourselves on is actually motion, which I think makes pretty good sense. So the title of chapter 11, the first physics chapter, is motion. And in the first section we have is titled distance and displacement. So those are going to be two big words we're going to use in this section, is distance and displacement. So to start, as always, we have our example, and a little cute example today. How fast is the butterfly moving and what direction is it moving? So those are pretty simple questions, but we're going to learn that to describe motion and to describe distance, it's not as easy as we might think. There's a lot of things we have to take into account when we describe how things actually move. So to describe motion, we first must state the direction that the object is moving, as well as how fast the object is moving, and you must also tell its location at a certain time. So there's a lot to consider in the term, when we're in the field of physics, when we think about the term motion. It's, again, we usually just think of it, oh, you're moving that way, that's your motion. There's a lot more to it. So one of the big things that you need to know to describe motion first is something called the frame of reference. So frame of reference is a really important vocabulary word that really, sets the stage for the rest of this probably chapter, if not the rest of this physics unit. So a frame of reference is a system of objects that are not moving with respect to one another. Now I'd make sure I wrote that down. I know that sounds confusing, but we're going to explain it more later on. But basically, in order to determine if something is moving, you first must compare it to something that you know is not moving. So that's what a frame of reference is. So if you are chasing, or if you're describing that butterfly back here, again, if you're moving as well, you're not going to be a very good frame of reference when we're trying to figure out how fast a butterfly is moving. If you're moving and the butterfly is moving, neither one can be used as the frame of reference. So your frame of reference might be how fast is the butterfly moving relative to that tree in the background, because we know for a fact that tree is stationary, it's an unmoving object, so maybe that tree could be a good frame of reference. Or how fast is the butterfly moving in reference to the ground, relative to the ground. So that's what a frame of reference is just choosing a non-moving object to compare to your moving object, which again is it sounds kind of complicated, but it's really pretty simple, and we're going to watch a short little video in class that kind of explains frame of reference a little bit better too as well. And we have a little example here that makes it a little bit easier to understand, and it's talking about a train. So a train is a good example of why having a frame of reference is important. So first it says, how fast the passengers on a train are moving depends on the frame of reference chosen to measure their motion. So again, what is our non-moving object, or what is our frame of reference that we're going to use to determine how fast the train is actually moving? And to do that, now we have something that's called relative motion. So this is extremely important. I would write down relative motion. It's the movement in relation to the frame of reference. So if you remember, I just said earlier, what's the butterfly is moving at relative to the tree, or what speed is the butterfly moving at relative to the ground. If I say relative to the tree, that's my frame of reference. Relative to the ground, that's my frame of reference, and then that is actually called, where did it go? Relative motion. So that's why I use that term there, relative to the ground, because we call it relative motion. So as the train moves past the platform, people standing on the platform will see those on the train speeding by, because they can use the platform as their frame of reference. So the train is moving past, we can measure the motion of the train relative to the platform. However, when the people on the train look at one another, they don't seem to be moving at all. So in this case, again, two people One person can be on the outside of the train, looking at the train speeding by. They can see two separate people go past them. Those people are obviously moving. Those same two people can look at each other, and they're not moving at all. That's because they have a different frame of reference for what motion actually is. So again, that's where it starts to get a little bit confusing. So that's why choosing a frame of reference is so important, because those two people on the train were moving at a very high speed to the people on the platform, but then when they actually look at each other, they don't look like they're moving at all. So how do we need to choose a frame of reference? So when you sit on a train and look out a window, a treetop may help you see how fast you are moving relative to the ground. Again, that treetop is steady. It's not moving whatsoever. That's why it would be a good frame of reference. The person sitting next to you is not a good frame of reference because they're moving right along with you. So they are not stationary. So finding that stationary object is a good way to choose a frame of reference. So another way is if you get up and walk toward the rear of the train, if you look at a seat or the floor, that will show how fast you are walking relative to the train now. So again, you get up, you walk. If you start walking towards the back of the train, now you're going to be moving past the seats. So how fast you're moving past the seats will tell you how fast you're walking, with the train being your frame of reference, because those seats aren't what's moving, you're moving. And then choosing a meaningful frame of reference allows you to describe motion in a clear and relevant manner. So I know this frame of reference sounds kind of confusing. It's really not that bad at all. Again, we'll go over a couple more examples in class. So frame of reference is the big important thing when we talk about motion. And now two other big ideas are something called distance and displacement. So these are both important, and we're going to hit on these. We're going to introduce them in this video, and we'll really hit them hard in our next one. So distance is just the length of the path between 2 points. So how far is it from point A to point B? How far did you move? That's distance. And displacement is the direction from the starting point and the length of a straight line from the starting point to the ending point. So that sounds confusing, but all displacement is how far, again, if I made it a more simplified version, how far are you when you ended from when you began? So if you ran 5 miles one way and then you ran 3 miles, okay, hold on, you ran 5 miles north, then you ran 3 miles south. Now, your total distance that you traveled was 8 miles. You went 5 miles one way, 3 miles the other. But your displacement is actually only 2 miles, because you ran 5 miles to the north, then you ran 3 miles exactly straight back. Now you're only 2 miles away from where you originally started. So we're going to do some examples with displacement within the next day or so, but that's just my easier way of explaining the difference between distance and displacement. And now we're just going to get another quick little introduction to each one of these. So distance is the length of a path between 2 points. So again, just how far it traveled. So when an object moves in a straight line, the distance is the length of the line connecting the object's starting point and its ending point. Pretty simple. Distance is easy stuff. I would definitely make sure you wrote that down though. And the SI unit for measuring distance is the meter. Remember, we talked about this way back in the first chapter. However, when you travel very large distances, it's more common to use the kilometer, and that's, remember, kilo is 1,000, so it's 1,000 meters. And then distances that are smaller than a meter are measured in centimeters. So again, remember, we talked about all of those prefixes and suffixes way back in chapter 1. So centimeter is 1/100th, so 100 centimeters are going to make up 1 meter. And then for displacement, it's describing an object's position relative to a given point. So you need to know how far away and in what direction the object is from that point. And displacement provides that information, and that's kind of, again, this is kind of convoluted, kind of a little bit confusing. I'll explain this more in class to make it a little more clear, but I think the roller coaster is a good example of displacement. So the entire length of the track that the roller coaster travels, that's its distance. So how long the track is from start to finish is its distance. Now, displacement is how far it travels, or where it ends up from its starting point. So a roller coaster, so hopefully you know, most of them just go in one big circle. So a roller coaster, after it completes, again, if you ride the Batman at Six Flags, you might travel a certain distance. Your distance, I don't know how long it is, it goes pretty quick. Your distance, let's say, is 50 meters, but it's probably a lot longer than that. But your displacement, once you make it back to the beginning, is 0 because your starting point is the same as your ending point. I think that's a better definition for displacement, is how far away you are from your original starting point. And like I said, we'll do some more examples with this. We're going to get an example of displacement in our next video, but we will hit on that more to make it make more sense. So that's it for the first part of section 1. Make sure you let me know if you have any questions.